Hello, and welcome to Unreal Engine 5 VR course that is mostly tailored for architectural presentations. What does that mean? Well, I'll explain it in just a moment, but while I give this kind of an introduction while I'm blabbing, let me show you what we will be working on, or working towards, I should say, throughout this course or throughout this video. Basically, in Unreal Engine 5.2, Lumen and Nanite have become stable enough to be used for VR applications. What does this mean? Well, Lumen enables us to use dynamic lighting as well as dynamic reflections, meaning that if the light changes its angle, the whole scene or all bounces of light inside of the scene will correspond without us needing to rebake it. This is a huge thing for photorealism in an architectural presentation. In terms of Nanite, it enables us to use really heavy meshes from, for instance, the Megascans library that we will most definitely be using in this course. What you're seeing now on the screen is me interacting with a bunch of blueprints that I have created, and I will be showing you how to make these kind of interactable objects for your architectural presentations, but that is going to come a little bit later, because the most important part, or the name of the game of this course, is optimization. How do you make your scene work with the hardware that you have at the highest possible quality? I will be using an RTX 3080 non-TI version graphics card with 48 gigabytes of RAM for this course, and considering that I'm going to be recording the screen capture at 4K resolution, the graphics card will most likely perform closer to 3060 Ti. So this should give you a pretty good understanding of what kind of hardware we're dealing with, and if you should readjust the settings that will be shown to get the same frame rate as what I'm getting. One last note about the files. So all of the files that I use in this course, as well as in every other video that I do for this channel, are available for the Patreon supporters. So if you go to the link in the video description below and you support the channel, you help out the channel, then you will get the list of all of the different files that you can download so that you can follow along this course much smoothly. With that being said, you definitely don't need the files to be able to follow along, because all of the settings are general, meaning that they will work on your files as well. With that being said, I think it's time to just jump right into it, and let's get started. Alrighty then, let's start. So, first of all, the headset, setting it up and making sure that it's connected to the computer. That's it varies very much between different headsets. The one that I'm going to showcase or the one that I'm going to use is called MetaQuest 2, which is the most popular headset, at least at the time of recording this video, because it provides the best bang for the buck, or price performance ratio in 2023. I believe the price of this headset is around $500, something like that. So to connect this headset to your computer, you will need to choose between two softwares, two different programs that you install on your computer. One is called Oculus App, O-C-U-L-U-S, Oculus App, and or rather another one is called Steam VR. The one that I'm going to be using is indeed Oculus App right here. So you just download it, it's free. You log in with the same account that what you're using for the headset, and you just simply go to your devices, click on Add Headset, follow along the simple instructions of what to do after which time, and your headset will be connected. At that point, it's going to be connected with a tether through a cable. But if you want it wireless, you indeed can have it wireless. So The only restriction is if you want a wireless connection with the headset, let me just change it here. You need to make sure that it's connected to the same Wi-Fi as the computer, which is going to be, which you are trying to connect to and which has the app. So here you can see that's my computer, and I can use the Airlink, which is the wireless connection, and I can click on launch. While this is launching, since you're most likely not all of you will have the VR, the same VR headset as what I have, and especially if you don't have the Meta Quest headset, you will most likely need to use TeamVR, for which I will not be showcasing the procedure, but it's pretty straightforward. It is pretty much the same. There are plenty, like so many tutorials on how to connect your headset through SteamVR, so just make sure to, quickly do a quick Google search and connect it that way. Basically, once you're with the Meta Quest, once you're in and you're connected to the computer, then you can start, for instance, let's go to desktop, let's check out monitor 1, and now I can see exactly the same thing as what I was showing you in on my screen, right? So that's like a, in doing so, I am sure that this headset is definitely, let's put it in here, that this headset is definitely connected to the computer, right? Let's move on to actually creating a Unreal Engine file. So to create a new VR project, you need to go to Library and just launch your 5.2 version. You can also launch it through here of Unreal Engine. If you have a newer version, hello people from the future, then launch that one instead. And after it initiates, we will be able to choose a template. And we will be using a VR template, of course, to start off with, but then we will make adjustments to it to raise the quality as much as possible. So I'll just go into games, virtual reality. I don't need the starter content, so I will have this unticked, and I'll just name my project VR YouTube, maybe underscore as well, and click on create. Once you start, it's going to compile all of the shaders. The first start is always longer, and then once it's done, we will continue. While I still have you here, I just want to note that this kind of course is a little bit one step above a beginner level course. It's going to be, I don't want to say intermediate, but it's definitely not a complete beginner course. If you want a complete beginner course, then please consider watching my previous video that I will leave a link to in the video description below, so that you get up to speed with how to create materials, how to navigate the scene, and so on. I will not be explaining those things here. I will be hyper focusing on the VR aspect of it and the optimization settings. Great, so now once this is loaded in, let's check if our headset actually gets recognized, first of all. So I will click on these three dots here, change play mode, and I will choose, I'll try to choose VR preview. And you can see that in my case, it's grayed out. The reason for that is because I have my headset right here, right next to me, and it's currently turned off. So I will put it on, and automatic face detection should turn it right on. There we go. And I also need my trusty controller to actually connect it to my, there we go, connect it to my computer, which turns on the Oculus app. Don't mind that one, actually minimize that. Keep it running, just have it minimized. So now with the headset turned on, let me double check. Yeah, that's good. With the headset turned on, if I click these three dots, now I can see VR preview option for the play as a play button. So play this level in VR, click on that. If I turn this on, I can look around. I even see my controllers. Wait, let me, this is weird. Let me grab those. No, let me grab those. There we go. And let's do some things. So let me guide you through the actual template. First of all, this is gonna be quite quick. If I hit something, I'm sorry, I don't see. So you're able to pick up stuff in this book. Drop that one. You're able to pick stuff up in this app or in this template, right? You're able to drop stuff. You're able to, okay, that I just hit the freaking microphone. I'm sorry. You're able to pick up a gun, shoot the gun, you know, and so on. So, and restart the game, blah, blah, blah. A bunch of settings. So it works great, but unfortunately this does not have Lumen, this does not have Nanite, and as you can see, the quality is not the best, right? So we need to amp up the quality while also making sure that the frame rate doesn't drop below a certain threshold. So that's what we're going to be doing. Let me hit escape here. So the settings that we want to work on are mostly located here under project settings, project and editor settings. So let me click on that and let's go to our project settings right here. Let me remove the headset for now. I won't need to use it for a while. And here, the first thing that we want to enable is, or make sure that is running, is DirectX 12. DirectX 12. Great. Default RHI is indeed DirectX 12. Then the next one that we want to check is called SM6. Direct3D, D12 target shader formats, SM6. Make sure that this one is tick marked. If those two are tick marked or running, that is already a pretty good start. So now let's start raising the quality. First thing and most important thing that I will do is I'll go to target hardware here, and I'll, instead of optimizing project settings for mobile scalable, no, we will use desktop scalable, which immediately asks us to restart the editor, which we will do. Restart editor. This might trigger a recalculation of the materials, the shaders, which it did not. That is great. Okay, so immediately the quality of the light and so on gets raised a little bit higher, which for us is great. That's what we want. Okay, next thing that we want to change is allow static lighting. Allow static lighting needs to be turned off. We want all of our lighting in the scene to be dynamic. So allow static lighting is turned off. Again, triggers, you can see it right here, triggers restart now operation, so we will be restarting it. There's going to be, as you can probably see, there's going to be a lot of restarting going on. And this time around, it does indeed recompute all of the shaders. Right, so let me pause the video and wait for it to do that. Okay, so after restarting, the light is all messed up. That is expected. Don't freak out. We will fix it in just a second. But before we do that, we need to do a few more adjustments to the settings. So let's finish up there. So again, in project settings, we will go for forward shading. And we will have this under forward render, forward shading, we will just simply untick forward shading, like that. Asks us to restart it again. No, not this time. You're not gonna catch me with that recompiling ever again. So we will keep changing things and restart everything all at once. So with forward shading unticked, for mobile, we don't care. We don't even look at mobile. We're just looking up towards forward render. Next one is going to be, I guess, Lumen. We need to check out Lumen. So at this point, I would suggest, instead of searching, let's just go to rendering. Where is it? Rendering. Hello. There it is. Rendering. Click here. And start kind of scrolling down. Definitely not mobile again. Start scrolling down until you see global illumination here. Make sure that it is set to Lumen. Reflections. Make sure that those are set to Lumen. Reflection capture resolution, 128 for our poor little computer is going to be too much. I would suggest either 64 or 96. In this case, I will be using 64 because I'm recording, so my computer won't handle probably 96. So that's the resolution at which the scene will be captured by the reflections. Last one. While it's doing this, let me just quickly check. Global clip plane, software ray tracing. Support hardware ray tracing, for sure. If available, it should support hardware ray tracing. It requires enabling skin cache. Yes, we enable that as well. With that being said, we don't use ray traced shadows or ray traced skylights. Those are too expensive, at least with the current hardware that we have, even if you're running RTX 4090. Okay, shadow maps, no, those are fine. Nanite, make sure that Nanite is enabled. Static lighting, we already disabled that. Forward shading, already disabled that. Those were important ones. And for VR, the HMD fixed foveation level, experimental, I have this disabled. Or rather, sorry, instant stereo, I believe that one was it instant stereo? One of these breaks or is able to break the preview, the shading preview. So if you will see this kind of a jittery mess in terms of the shadow casting, then make sure to go in here and disable instant stereo as well as fixed foveation level right here. Change those to disabled. That will fix it. If we will see this happen in this course, I will make sure to go in here and show you that these settings are the ones responsible for that kind of behavior. Right now, without it happening, it's very hard to show. Auto exposure, I personally prefer to have auto exposure on so that it exposes properly the scene, and later controlling the auto exposure with post-process volume. And last one is going to be anti-aliasing method. I use temporal super resolution, TSR method right here, with the sample count set to, I believe, no MSAA right here. I think. Sorry. If it messes up, we will fix it. But for now, let's go for no MSAA. Then if we go even lower, or perhaps it's in another chapter, let's just search. Let's go back to all settings here, and in the search bar, type in effect height. Yeah, there we go. Support sky atmosphere affecting height fog. That's an important tick mark to have. So let's tick it. Great. Once that is done, we're kind of finished with the general project settings. Let me restart, save selected, sure. And after it restarts, after it recompiles, we will continue on with fixing the light and so on for our scene. There we go. Now this is starting to look pretty convincing. With Lumen enabled, you can see the shadows are much more realistic. The guns produce pretty cool shadows. The darkness there is still, not that great, but if I select the light source, make sure that you have this changed from, let me go here, from static into movable, and then it begins shining light, right? And it's all dynamic, all dynamic. That one as well, you can have it movable, shiny. So with that being said, I will not be using those light sources. I will be just deleting them all together. I'll delete that, delete these guys. Well, maybe this is pretty cool. I'll keep that. And I will just be basically stripping away the template file into something that has less, because I don't need it to be as big to just test things out. What else is there? The reflection capture, our sphere reflection capture, we don't need those anymore. And actually for the light, let me show you how I set up the light for a lumen scene. So let's first of all get rid of all of the light that we have. Just going through this navigation, or sorry, the outliner, I will select the directional light, I will delete that, keep scrolling down until I see the skylight, delete that, sky sphere, delete that. And that's it, right? Light mass importance volume, don't really need it for now, delete that. Okay, anything that has anything to do with a light, I have deleted. These guys are still a little bit glowy, but that's okay. Then under window, make sure that environment light mixer is turned on. So tick mark that. A new window will pop up, which you can dock here in the bottom, where you can create skylight, atmospheric, blah blah blah. All of these different light creation tools are available to you. The environment light mixer, in my opinion, is a highly underused tool. So create skylight like that, create atmospheric light like that, create sky atmosphere like that. Let's look at the sky. There it is, doing its thing. Create volumetric clouds like that. Preparing the shaders. Give it a second, it's gonna kick in. And then create height fog as well. Bam, like that. And then for the height fog, I can increase its density here to have it a little bit more or less foggy. I can also make it volumetric fog. Let me move myself here, I guess. I can, here under exponential height fog, I can tick mark volumetric fog right here. So it's going to be more accurate. In this case, I don't need it to be that accurate for now, so I'll have it unticked. Okay, these are all default settings. By the way, if your sky is black, make sure that you go back to the video and where I said the effect height fog setting, project settings, effect height fog, support sky atmosphere affecting height fog. Make sure that this one is tick marked. It's going to work then. Okay, one last thing before we actually start the VR preview. I'll go for, I believe, advanced settings. Okay, our first little crash here. It is what it is. So what I was doing was clicking these three little dots, going to advanced settings and choosing new viewport resolution to be 1920 by 1080, so that the preview that you see is a little bit larger once you start running the VR template. Besides that, not much has been changed. All of our like shadows and so on, you can see that automatic exposure kind of works here, and everything is neat and dandy. All right, so we can actually move forward. We need to drop down the quality by quite a bit for this to work, because this is still too much of an overkill. So the first thing that I'm going to do, I'll go to my project settings, and I'll go to rendering. Where is it? Rendering. There we go. Scroll all the way down until you see VR. Where is it? VR. And here I'm just going to choose to untick instant stereo, because now I'm 99% sure that this is a problematic tool as it is right now, but instead I will use HMD fixed foveation level, and I'll choose it to be medium, dynamic fixed foveation experimental. I will have this tick marked. So medium tick marked instant stereo, turn that one off for now, at least. Besides that, everything here seems to be okay. It asks me to restart. I will not be restarting just now. I will be creating one more thing here to drop the quality of Lumen by quite a bit. We need to drop it by quite a bit to make this work. So under quickly add to the project, under this button right here, under volumes, I will create a post-process volume simply here. In its settings, restart later. In its settings, I will go for unbound, infinite extent, unbound setting. I will tick mark that. And then here I will start changing up things in terms of bloom and so on. So the first thing that I want to do is change the exposure. I think exposure compensation here is a little bit of overkill for on the bright side, right? So it's a little bit too bright. Let's do 0.5, something like that. So we just darkened the scene a little bit. Once you put on the VR headset, you don't want things to be overly bright. Then in terms of lens flares, I want their intensity to be 0. Lens flares, at least for me, they really mess up my perception of what's far, what's close, really gets into my eyes. So I will tick mark those and make them 0 intensity. And then last thing, or not last thing, rather, if we scroll down here to global illumination method lumen, that's great. And where we see lumen global illumination, I will start messing around with these settings. Give me a second, I will play around with these to see what works the best. Okay, let's try this out. So we are dealing with lumen global illumination set to lumen scene view distance set to 1000 millimeters, or sorry, 1000 centimeters, which is 10 meters. Max trace distance also 10 meters. Lumen scene lightning update speed 0.5 and lumen final gather lighting update speed 0.5. Those are the settings that I have changed here. Then in our project settings, I've also worked on here. If we go for back in the most of the settings, by the way, are under rendering. I have changed the where is it? I have rather not changed, but noticed that we are not using ray tracing. So I have, am I blind? Hardware ray tracing, hello? There we go, support hardware ray tracing, that was tick marked, but under Lumen, I didn't use hardware ray tracing when available. So make sure that this one is ticked as well. With those done, we should be kind of good to go to test out if this is gonna crash or not. So let's see. I now put on my headset. Takes a while. Okay, how are we doing with the frame rate? It says 45. I'm happy with 45. Let's stat GPU. Let's go for stat GPU, and everything seems to be quite nice. Okay, so we're at around 60 frames per second. One trick that I am using is the scalability, which you can enable if you go to your, let's go here. If you go to settings, engine scalability settings, and you play around with the scalability right here. So I'm using medium for everything except for global elimination, where I use high. Let's see what happens if we go full blast with high for everything. You can see, by the way, that the quality immediately jumps, but also the frame rate immediately drops. So we'll see. Let's press play again. Now we're at around, what is it, 30? Right? Yeah, at around 30 frames per second, which is not ideal. But if I wasn't recording this this video, this would be just fine. Oh, now we're back to 45, so maybe it was just a hiccup. Okay, so now this, in terms of light and lumen, we're kind of done. Now the next step is to actually introduce Nanite into the scene. And Nanite is already, oh, by the way, let's turn off the profiling. So let me type in tilde key. That's right below the escape key. You have the tilde key, and type in stat GPU to turn on or off the GPU profiling table. Then tilde key again, stat unit to turn on and off the timings in milliseconds of the performance. Stat unit, let's turn that off. And the FPS, I will keep the FPS so that you can see it. We're at around, well, actually now we're at around 60, well, 50, which is great. This is working just fine. All right. Okay, so with this done, let's move on to our next step, which we will call Nanite everything, and also import an actual project into this template. All right, so let's talk about Nanite before we actually start importing things. Because here in this scene, while Nanite is indeed enabled, it's not being used. What I mean by that is if I go to the preview settings here, which is currently lit, and I go to Nanite visualization and I choose triangles, you can see that only these objects right here are running Nanite. Everything else is not. So we need to make sure that all of the objects here that we currently have in the scene is already Nanite. First of all, what is Nanite? That is a dynamic geometry optimization tool which works like magic that Unreal Engine people have developed, which enables us to have really high complexity models in our scene without sacrificing too much of performance. So before we move on, I will delete a bunch of stuff here in the scene because I don't need it, and I will just keep just the platform. There we go. Just the platform, you know, and this kind of a playing area here, just so that we can carry around some stuff later down the line into the interior of our house. So everything that is left, I want to make it into Nanite. How do you do that? Well, for instance, this object right here, which is floor, right? I can just navigate to where the static mesh is, which is SM Cube. I click on this browse to SM Cube in content browser. There we go. And it's going to show me all of the objects here that, are used in this scene. I think most of them. So I'll just select all of them, holding down the Shift key, right click on them, and where it says Nanite, I will enable that, tick mark that, right? Takes a little bit of time, recalculates. Let's just double check. Yep, that is tick marked. Great. Now if I go to Nanite visualization, triangles, I can see that indeed these objects are now Nanite. There is one object that is not though, and that is the gun. So let's select, well, let's go to lit mode. Let's select the gun. And in this case, the pistol is actually a blueprint, right? So we can't directly access its 3D model through here. We need to actually go into edit pistol right here, which will open up the blueprint of it. And where we see skeletal mesh gun, where is it? Oh, there we go. Skeletal mesh gun, under mesh, we can navigate to it. See? So skeletal mesh asset that is being used. I click on this browse to, and now if I close this in my, how do I say this? In my content browser, this gun mesh will be selected. I can right click on it, and then remember that it actually cannot be Nanite because it's a skeletal mesh. I'm being stupid. Never mind. So we keep it the way it is. We don't change it to Nanite. And it's me who's recording a course, huh? Forgetting that skeletal meshes cannot be Nanite. Anywho, let's start importing things and changing them into Nanite as well. So to import, we will be using Datasmith for that because I'm a Rhino user myself and all of my 3D models are in Rhino, and in architectural field, you usually either use Rhino or Revit or ArchiCAD, so you will be using Datasmith. First of all, you need to make sure that Datasmith is used in your project. So you go to Settings, Plugins, type in Datasmith, and make sure that Datasmith CAD importer is tick marked. If it wasn't, tick mark it, restart your project. Sure, save selected. It's going to restart, and then you can see all of my recordings for this course already. A lot of ticks. So once it resets, then restarts, then you will have your Datasmith import option right here. Whoops, sorry, under here in the top. Add, quickly add to the project, Datasmith file import. I already covered this in the previous video, the introduction to Unreal Engine 5 for architectural visualization. So if you want to learn more about this, make sure to check out that video. So I'll click on file import. Actually, sorry, before I do that, I will create a new folder in the content folder. Just call it new folder, call it house. There we go. Double click there. And now under quick add button, Datasmith file import, I will navigate to one of my buildings that I use for rendering examples. I think we will use the same one as what we did for the previous course. So under Unreal Engine 5 Datasmith, base model, there we go. Open up that one. Navigate to the house folder, hit OK. Asks us what do we want to import. In my case, it's only the geometry. I click on import, and it's going to slowly get everything in here. Give it a second. These files, by the way, I keep pushing this, I know, but they are available to Patreon supporters. There were some issues. Let's see the message log. Can't find one mesh. That's fine. That's probably just my mistake. Anyway, so now this model gets imported. It's pretty far out. So let's just select one of the objects here, press F to zoom in. Here it is, and it's climbing right on top of our nice little platform, right? So I need to move it slightly away, or I need to move the platform away. In this case, I will do that with the model. So here in my outliner, I will choose base model right here, because that is the main kind of compartment, main folder that holds all of the geometry. So base model, and I will just move it away, maybe to here, something like that. I prefer, yeah, I prefer this, something like that instead. Okay, great. So now there are a few things that I want to fix. Thing number one is this platform right here, this box right here. I want its size to be different. I don't want it to be that big. I don't want it to climb into the house. So here for the scale, I will just simply change the X scale of it so that it stops right before the terrace. And maybe we can even make it even smaller, something like that. And please stop before the terrace begins. The ball should be somewhere here, maybe. Okay. Just small adjustments, bear with me. I want it to be neat and tidy. There we go. Okay, so that's done. That's our post-processing volume that can just live somewhere. Actually, that can live anywhere in the scene. I will just have it to the right. And our camera for navigation or for external view, we can just change the angle of that camera to something like this. Yeah, should be fine. Okay. I think we are kind of ready to start working on this geometry right here. So our base model, as it's imported as a Datasmith file, will have a geometries folder inside, which we double click, and here we have access to every single mesh that is used for this model. So what I do is I select every single mesh, I right click on them, I choose Datasmith, I choose Nanite, and I choose to enable Nanite. Bam. Quickly, really quickly recalculates the geometry to work with Nanite. Okay, great. So that works. Then next thing to do is actually to find every single object that is within the glass layer. This is important. Every single object that is within the glass layer, we browse to those objects. Hello? Are these selected? Give me a second. I'm just gonna make sure that we are selecting them. Perhaps we are not. While I'm investigating this. Oh, they're right at the start. While I'm investigating this, the reason why, yeah, okay, we're not selecting them. The reason why we are fishing out the glass objects is because Nanite currently, at the time of recording, cannot have translucency, meaning that all of our objects that are glass, these guys right here, they need to not be Nanite. So I'll have this disabled or unticked. Please, untick. There we go. All right. So now I think we need to just check the performance if that is being hit too much. So let me turn on the headset. Okay, Airlink connection lost. Give me a second. Do that. Do that. That. Come on, launch. There we go. And now I should be able to play this in VR. Okay, how's our resolution? That is not too bad. This time around, let's walk. So if I try to walk right now, am I? Yeah, there we go. If I try to walk right now, I'm able to wait. Am I talking into the microphone? I'm able to walk right up until the end of this platform, but I can't walk any further. And that is for a good reason. There's no navigation mesh, meaning that the... I really want that gun. Meaning that the game does not enable us to walk. Also, one more thing, notice the collisions. They're not working, right? Well, first of all, the gun bullets don't bounce around. We will fix that in just a second. But also, if I were to walk towards there, the collisions wouldn't be accurate. So I need to change two things before we can say that the geometry has been successfully imported. First thing to change is the collisions. So again, selecting every single piece of geometry in our scene, just like that, right click on them. Not in our scene, but in our imported scene. I will choose asset actions, and I will choose bulk edit via property matrix right here. This enables us to edit for instance, the collisions in this case for every single piece, for all 1681 static meshes. So I'll go to static mesh, I believe. Let's just type in collision, double L, COLLL, collision. Collision complexity. Instead of project default, we choose use complex collision as simple. That. So that means the geometry of these static meshes is going to be used to calculate the collision, which is quite important. Save all. File, save all. Once it's done, you can close it and move on. So that's step one, making sure that the collision works. Step two is going to be making sure that that we're able to navigate to the mesh or to the building, right? So with this closed, let's check out the navigation. If we look closely, which we won't, but let's try. Yeah, there we go. That's the navigation mesh bounds right here. There is this actor called nav mesh bounds. This actor, if I remember correctly, is it G? No, it's not G. Is it tab? No, it's not tab. Caps lock? No. Oh no. 1 second. I need to check. Oh, actually, we can just do this. For perspective, we can choose cinematic view, and it should show us. No, never mind. It doesn't. Okay, give me a second. Okay, I've just simply forgot. It's the letter P. P as in pineapple. If you press that, there we go. It shows you what that navigation volume is going to be, well, navigating, I guess. So where you will be able to move around. So in our case, we want to take that volume and move it slightly over here. Something like that. Maybe a bit larger here. And we just want to make sure that we're able to navigate inside of this room, right, all throughout, and also around the building. So I need to actually make it a little bit bigger, which you can do by, is it? No, it's not changing the scale, or is it? Now I'm scared. No, it's brush settings. Yeah, it's brush settings changes the size of it, right? So that's X, that's Y, like that. Something like so. And the Z, we will work with the Z in just a little bit, but the Z basically controls how far you can move, right? So not how far you can move, but how high up you can move. So if I were to increase the Z here, in this case, for instance, the table, if I increase the Z to 2 meters, then we can also jump on the table. In our case, we probably don't want it, so I'll make it a little bit less, like 50 centimeters. This should be enough for us to be able to navigate through most of it, even on top of the sofa, which I kinda dislike, so let me do it a little bit less. 20. Okay, 20 is a mistake. 30. 40. There we go. 40 gives us the possibility to move around most of it, and kinda the sofa as well. It's actually fine. Oh, but also, since this platform is raised, we're not able to move here outside. So we actually do need to have it pretty high up. Let's go for 70 then. Whatever. I'll use 100. That's fine. Okay, so that kind of concludes, and press P to stop the preview. That kind of concludes the import portion. Let's just check if it works and if I didn't make any mistakes and if the frame rate is still acceptable. Press play. Okay, how are we? Kind of good, ain't gonna lie. Oops, sorry about that. You can see me putting on my hands. So now let's do this. Let me move slightly away so that I have more room. Of course, the microphone is right at the come on, the table as well. There we go. The microphone is right in front of me, so it's a little bit annoying. But now if I just throw it, you can see the bounce, right? Let me do that again. Come on. Oh, where is it? No. Okay. Usually you do this in a room rather than by the computer. So you want like a lot of free space for experimentation. This still does not work. That's because the problem is in the bullets, right? Of this gun. It's not the problem with the collisions of the house, because you saw that the box, for instance. Come on. There we go. You can see that it bounces quite well. Okay, let's go around and see. Yeah, it seems like the exposure works quite well. I know, I look like an idiot right now. I hate how people look like with VR headsets on, but hey, it is what it is. Okay, so the house looks fine. I will be texturing it next up, and we will be going inside of it. Because right now, if I go inside of this house, that's not gonna be great. Let's see if I'm gonna be able to. Come on. No, it doesn't catch it. Maybe if we go here. There we go. So now I'm inside of the house. You can see automatic exposure kind of starts picking up, but the fact that it does not have any openings really messes with it. So that's the next thing that we're gonna be fixing. All of this is gonna be glass. Okay. Next step. Let's go. It's gonna be materials. Alrighty then, let's talk about materials now. So in terms of VR applications, the materials are pretty straightforward. It's the same approach as what you would do for any architectural visualization project, except for glass. Glass is still quite quite expensive, so I will show you how to create a cheapest, so to say, performance-wise, glass material that we can. So under our content folder, I'll just create a new folder, call it materials. Double click that. And here, just right clicking on the empty space, I'll choose to create a new material, like so. Call it glass master. Great. Now double clicking this material, a new tab is opened that I can drag and drop right here, dock it, so that we have two tabs here available for us. And in this glass master material preset, or not preset, just material, we're going to apply the base color, the specularity, if I remember correctly. No, sorry, base color, metallic, how metallic it is, the roughness, and the opacity. As you can see, the opacity is not available for us currently, so we need to change our material blending mode from opaque to translucent. There we go. Once we've done that, now the opacity is possible, but the problem now is that everything else is kind of gone, right? So I need to change the shading model, or sorry, not the shading, the lighting model. Lighting mode from volumetric non-directional into surface translucency volume, like that. Okay. So now, what kind of a color, base color and so on do we want? Well, I'm just going to create a few numbers here because we'll go grayscale, so all we need is just single values between 0 and 1. So for the base color, let's just hold down the key number 1 or key 1 in your keyboards, press 1 and hold it and click your mouse. This will create this parameter node, or not parameter, sorry, the scalar node. You can also type in here, right click here anywhere on the screen and type in constant. Sorry, I just woke up, I need a minute. You type in constant and you can choose that. It's the same thing, right? So the shortcut for it is just holding down the key number 1 and pressing your mouse button. Okay, and here I'm just going to change this into a parameter. So I'm going to right click on my, my constant node and convert it to parameter, like that. And call it base color. There we go, base color. Connected there. Now I'm going to copy this base color node, Ctrl+C, Ctrl+V, and drag it just a little bit down. I'm going to select it, and here on the left-hand side, under parameter name, I'm going to change this to metallic and connect it like so. And that's the name of the game. We need two more nodes, one for roughness and one for opacity. So I'm just going to borrow these two, drag them all the way down here. One is gonna be connected to roughness, one is gonna be connected to opacity, and I just changed their names. Roughness. And I'm lazy, so I'm just gonna say OPA. OPA for opacity. Okay. What kind of values do we want to work with? Well, for base color and metalness, how metallic it is, we want ones. So I'm just going to say that the default value is 1 here and 1 here, right? Then for our roughness, we want it to be slightly less rough, sorry, not perfectly smooth, slightly rough. So I will go for 0.96, something like that. Or is it other way around? Is it 0.04? Well, we'll figure it out. And then for opacity, I will go for just slightly opaque, 0.1. You can barely see, let me go for 0.2 so that you can see better, 0.2. You can kind of see the glass right here. It does not change, it does not bend the light, it does not do anything because we will be using it just for the flat sheets, right? So we don't need it to do anything more than what it's doing right now. Actually, the roughness, let me see. Yeah, okay, so 0.1 roughness creates the reflection much better. Sorry, it needed to be opposite. So 0.06, right? Something like that for the roughness. I was thinking of glossiness. So again, 1 for base color, 1 for metallic, 0.06 for roughness, and 0.2 or I would say 0.1 for opacity. Let's save that. Close that. Let's create a derived material instance from this glass master material. I'm just going to create a new folder, call it instances. Right click on my glass master material and choose to create material instance like that. Call it glass, just glass, and drag it over or move to my instances folder like so. Okay, great. Now let's apply the glass material to our windows. So to do so, I'm just going to select one of the windows, and immediately on the right hand side, it gives me the glass layer where all of my windows are placed. That is because in Rhino, as I was modeling it, I placed all of the geometries that will be glass preemptively into one layer, and just drag and drop in my glass material after selecting all of them into this material tab right here. Bam. And then we have questions, I guess. Why the hell is this not working? The first assumption that I have is that these geometries are still Nanite, and Nanite does not deal with transparency or translucency. Let me double check. So this guy right here, I just click on this browse to BREP 17 in content browser button. Right click it in the content browser, go to Nanite, and yes, indeed, Nanite is enabled for it. So if I untick Nanite or if I disable Nanite, you can see that now the translucency actually works. Let me just check one thing real quick to see if maybe in 5.2 they already fixed it. So here in my glass master material, if I type in Nanite, yeah, okay, used with Nanite, that's tick marked. And unfortunately, yeah, unfortunately, it still does not, the translucency still does not work with Nanite. That's okay. Okay, so what we need to do is we need to disable Nanite for all of the glass that we will have. Let me just quickly browse. And I believe it starts in BREP 12 and ends in BREP 33. That's going to be fast. BREP 33, like that. Right click, Nanite, disable Nanite. We're done. Easy peasy, lemon squeezy. Okay, so that's glass. Yeah, we're done with the grass part. Now, in terms of actually applying photorealistic materials, we will be using, of course, the Quixel bridge. This button right here, Quixel bridge, which gives you this little tab right here. If you don't know what this is, again, suggest looking at the beginner course, link in the video description. But basically it's a library, right? A library of materials that you can use with, not just materials, assets as well, that you can use with Unreal Engine. So in my local already downloaded assets, I have like a banana and stuff. And I have plenty of geometries already downloaded, and I'm just going to get a few of them in here. So let's start with, let's say floor. Yeah, why not? Chevron, walnut, parquet. Export medium quality. Bam. Immediately arrives here. We have our textures, we have our material. Great, we're good to go. So here, I'll select the floor. I can see that I do have a, how do you call it? Like a layer called parquet, or actor in this case. And all I need to do is just this material instance that we have downloaded, I just drag and drop in to here. Give it a second. It needs to calculate. And now we're good to go. Now we have a pretty convincing floor. Neat, huh? I like it. All right, so that's, I'm going to, of course, not show you the whole process, or rather I'm going to speed up through the whole process of me slapping on all of these materials. But before I do so, one last thing to show is the assets. So in VR, we can't really have a lot of trees. That's too heavy. So instead we will need to do some sort of a more of a Icelandic landscape vibe instead of forest vibe for this particular shot. So let's go for home, 3D assets, nature, I would say probably rock, volcanic. Yeah, and we have like a bunch of Icelandic rock formations and whatnot. So I'm just going to, I should probably just download one of these. I think I already have one of these, so let me just quickly. Now I just have forest floor, huge mossy rock, embankment. Apologies for making you wait. Everything that I have is forest based. Forest rocky embankment. Okay, so I do indeed need to download something here. 3D assets, again, nature. Let's just see embankment for a second. Tundra. Tundra rocky ground. We can get that one in here. Why not? Okay, so I will just select it. You make sure that you first select it and you change the quality from medium into nanite. Nanite? I click on download. Now it's going to take a little bit of time to download because this is not, a lightweight piece of geometry. So make sure that as you're downloading these guys, that you are not, what's the good word? You're not overexerting, or you're not overcomplicating things. So to say, you don't have too many elements, different elements, because even with this single patch, you can create a pretty varying scene by just simply copying this patch, right? The more of these different patches you have, the more complex, the more requirements the scene will have, and the more your graphics card will suffer. While it's doing that thing, I'm going to also actually mossy forest ground, that's kind of no, never mind. I'm going to download this one and maybe this one as well, these three. Okay, while it's doing its thing, let's go to local. And let's just see if there is any kind of a, well, that's wall, but we might be able to use that. Any kind of materials that we can already kind of get up on our geometries. For instance, the roof, the slate roof. I'm going to export. By the way, the materials are in medium quality. It's just the difference between medium and high material quality is not big enough for me to say that the graphics card should take the hit. So same. Okay, so we have our tiles here, and I'm just going to put up the roof, and voila, we have now our slate roof. As easy as that. Let's check if the 3D model has downloaded. Probably has. A filter, types, 3D assets. Do we really need to restart for it to register? Okay, fine. We're gonna go the long way. Oh, never mind. It just downloaded. Come on, show me. Yeah, there we go. Tundra, rocky ground. Export nanite. It gives us the nanite mesh in here. It's going to prepare it, and once it's done, we can just slap on. Oh, sorry, that's the material instance. Make sure that you're not applying the material instance. Instead, you're taking the static mesh within your Megascans 3D assets Tundra rock. You just drag and drop it in, something like that. And shall we take a look at it, at its quality, and also add a hit in the performance that it's going to give us. E to rotate, by the way, W to move, R to scale. Something like that. One second, I'm going to grab my grabbing the headset. Okay. Okay, we should be able to play now. It's still loading. If I just zoom in here, you can see that the quality of the asset is pretty damn good, but we need to make sure that it does not lag out our VR application. So let me press play. How does this look? Okay, it looks pretty good. Let me just do a quick stat FPS and stat unit. Okay, so we're at 45 frames per second with recording the video, meaning without recording the video we would be closer to 60. And if I'm looking at the ground, we're maintaining the 45 frames per second. Let's look at the glass. If that is, whoop, 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 whoop. Yeah, that also retains. Nice. That also retains the 45 frames per second. I'm happy with that. Okay, one more test, and then we will do fast forward. I'm just going to take this mesh, and holding down the Alt key, I'm going to make a copy of it. E key, I'm going to rotate it. Like that, or maybe even like that. Place it right here. Then maybe one more. Alt key. E key. W. I just want to see if having 6 of them, for instance, if that is going to destroy the performance or not. This will inform me if I can use nanite meshes to tile the whole environment. So let's try this again. We were at 45. I can't see. Where am I? Press play. Come on. Okay, that took a while to load in. It seems like there is a little bit of screen tearing in one of the eyes. That's the wrong arm, sorry. Let's see if that is... Seems to be okay, except for a glitch in one eye, which I think is due to... This might not be... Yeah, you don't even see it on the screen. This might be actually due to the recording. So I'm going to stop the recording right now, and I'm going to check, just simply check if it still messes up, and if it does, then we will need to investigate. But if it doesn't, then it's from now on it's going to be a fast forward of me applying the materials. The process is the same: download, slap on until the environment is pretty. So I don't want to do too much with it, but we do have ourselves a little bit of an environment that should be good enough for me to kind of show you that we indeed can use Nanite with VR. And now, before we finish with on the materials and assets side, I kind of want to just show you the gun part and how you can use that to really explore the possibilities of Lumen. So let me press play. What we're gonna try doing now is create collision for these balls that it's shooting, and also try our best to create a material that shines light. So the balls would shine light. So 1 second. So in terms of the material, first of all, I guess, all we need to do is just go to our materials tab, create a new folder, create a new material, call it emissive. There we go. Go in here, change the base color to actually whatever color you want, and change the emissive color to whatever color you want. So I'm going to use constant 3 vector for the base color, which actually does not really matter. So it can just be black, because black body will shine light either way. Like that. Copy paste, plug that one into... Actually, we choose a color let me explain this better. We choose a color for the emissive, right? So that's the color that it's going to shine. This black body is gonna shine. So I'm just gonna choose whatever color there is, like that, pink, sure, like that. And also I will apply strength. So that's how strong the emissive material is going to be. So I'm going to multiply by a constant, right? So that's again me holding down the number 1, clicking, and creating a constant node here. Connect there. There we go. And now we apply it or connect it to emissive color. Since the constant right now is set to 0, that's no good. So I'm just going to change the constant to, well, actually, let's make it parameter and call it strength or emissive strength. And change the color, convert to parameter, call it color. There we go. Save that. Close that. Let me hide the nanite, all nanite meshes, so that's a little bit faster. Then for this emissive material, I'm just going to duplicate it. Or sorry, not duplicate it. My bad. We don't do that. I'm going to right click, create material instance, and call it emissive 1. Emissive 1. Just drag it into my instance folder like that, move there, double click, it's now here, double click on it, and let's edit our material instance. So I'll tick mark the emissive strength as well as the color, and as I'm increasing the strength, you can see that first it gets a color and then it's going to start shining light. So I'm going to go for something like 20. I have no idea if that is strong enough, but we will try. And now I want the bullets that these guns are shooting to, first of all, bounce, and then to be using this emissive 1 material. So I'm going to select one of the guns, going to go into its blueprint, edit pistol, right here. And here, just by reading the blueprint, I can see that spawn the projectile, there we go, spawn actor projectile, class projectile. So it's basically every time you press the button, it spawns this actor of this class. So I'm going to click on this browse icon right here, and it immediately gives me where that actor is located in our content browser. As per usual, I will double click on it, and here I can change anything I want about the projectile, right? So just seeing, looking at what we have here, we have sphere collision, that's perfect. We have static mesh, great. And we have projectile movement. So to make it bounce, it's actually super simple. You go to projectile movement, and here on the right hand side, you should tick mark, should bounce. That's it. And then to change the material, you go to static mesh, and you change element 0 material to emissive 1. Like that. Compile, save, just in case, save that one as well. Press play. Okay, fine, this works. And now with this, boop, boop. Yay. Well, those guys don't have collision, or they kind of do, don't they? A little bit, but they don't have accurate collision, so that won't work. But now we have ourselves like a gun that can shoot stuff that is, let's go there, a gun that can shoot stuff that should shine light. Oop. How cool is that? Let's go to somewhere dark. Boop, boop, boop. Pew, pew, pew. Nice, huh? Kinda like it. Hello? Where am I? Oh, we're in the bathroom. Boop. They do have a like a lifespan, of course. It's a nice bathroom, isn't it? Oh. Boop. All right, so that works. Put it in there. Okay. Now since we're done with this part, next up is going to be us creating like a blueprint to open and close doors, which is super to go for more dynamic things. Yay. Okay, I'll see you in the next chapter. Okay, actions. Let's make it possible to open up a door with one of these, right? Let's say a trigger button like so. So to do so, we need to first be able to understand where we're pointing, for Unreal to understand where we're pointing when we are actually pushing the trigger and so on. And with Unreal Engine 5.1, I believe, or 5.0, now we are using enhanced action mapping, I believe it's called, which has a little bit different of a system for actions and like recording keys and whatnot. So this one is going to be a little bit more of a follow along. The first thing that we need to do is we need to create an action that will be mapped to us actually pressing the button right there. So to do so, let's go to our VR template. Let's go to, it should be under input. There we go. Perfect. Under input, we have all of the different states in which the inputs are registered. The default state is the one in which we are spawned into, and weapon state is when we are holding a weapon. So the different inputs change what they do when you're holding the weapons. In this case, we will be editing the default state, but not just yet. First of all, we'll go into actions and we will create two actions. So I'll right click, I'll choose input action, and here I will name it R underscore interact, or sorry, let's just do input action IA underscore, oh, you don't see it, my bad, there you go, IA underscore interact right. IA underscore interact underscore right. Hit enter. Double click it. You will see all of the different settings that that action can have. We don't really need to change anything about this, at least to, let me actually double check. I don't think we need to change consume input. Yeah, all of this is fine. So we can just close this. You don't even need to open it up. Okay, so we have our interact right action. And now I'm going to just duplicate it like that and call it IA interact left. You can also just create a new action and name it that way. Doesn't really matter, but we have IA interact right, IA interact left. Okay, great. To call these two actions, we need to go back to our input folder, and where we have input, how is it called? Mapping context, input mapping context underscore default. If we double click that, then we will have all of our different mappings right here. So IA move, turn, and if I expand that, you can see that for Oculus Touch, thumbstick y-axis makes us move, right? So here we actually need to add our two new mappings. To do so, I just click this little plus button right here. There we go. New mapping was added. I'll expand this and I'll just type in IA underscore interact. And let's start with the left one. Left. There we go. Interact left. Okay. With this done, now I need to actually say what triggers the left interaction or interaction of the left arm. So I need the correct left controller, like so. And basically it's going to be this trigger, right? So expanding this, I can go to my Oculus Touch and find Oculus Touch left trigger axis right here. There we go. So once I press this button in the default setting, the interact left action will be called forward. I will repeat this for the right hand side. So for the right hand side, one more second. No, nothing else needs to be changed. Okay, so for the right hand side, I just create a new one, choose here, interact right. There we go. And Oculus Touch where's trigger axis? There we go. Once that is done, we just save, close. Now we have the two actions actually made and ready to go. So how do we call them? Well, we should call the actions inside of our player character or player pawn. The player pawn is located under VR templates, blueprints, VR pawn, right here. Double click that. And this whole behavior chain or menu will pop in. And just to kind of explain, let's say here, enhanced input action IA turn. If you start that action, then your character will the turn will snap to the right. So you're turning by, I believe that is going to be 90 degrees, or maybe it's a smooth turn. I'm not sure. I don't remember. Sorry. I believe it snaps to 90 degrees, right? So stuff like that. So we're creating these kind of actions to trigger a certain event that happens in the character. So in our case, we're going to create a new one, perhaps right here. There's plenty of space here. And I'm just going to right click and type in IA underscore interact, and let's go for the left one, or let's go for the right one actually. Interact right. That's I'm left-handed and all of my stuff is on the left-hand side, so for me my right hand is a little bit more free. Okay, so once that is set up, now we need to say, okay, once the action begins, once I trigger the button, what happens, right? And what needs to happen is we need to shoot out a beam from our controller just outwards, straight forward, and see if that beam hits anything, right? It like shooting a gun. So when we start an action, there needs to be a line trace by channel. Line trace by channel needs to happen, right? Line trace by channel. There we go. And basically a line trace is, it has a starting point and it has an end point. So it's like a line, right? And whatever the line hits, we get it as an output here, you know, whatever object is being hit by the line. So our start should be where our controller is currently in the world, right? So to do so, I need to first get the motion controller in here. And I will just type in get motion controller data. No, there should be something else. Sorry, 1 second. Motion controller left or right aim. Oh, there we go. Get motion controller right aim. This one right here. That's the one that we want. Bam, I get it. From it, I can extract a get world location. There we go. And that is going to be where, you know, the position where the beam should start from. Then the end of the beam should be, well, basically we need a direction and we need a length for how long the beam is going to be. So to do so, I'm just going to Again, I'm dragging out from get motion controller right aim, dragging out, and I'm going to type in get forward vector. That just simply goes out, right? So our forward vector, actually I'll need like a Microsoft Paint for this. Okay, so let's say we live in 2D world, right? And we have we have two axes. Actually, can I just use a brush, please? There we go. Beautiful. Two axes, X and Y, and this is 0, 0, 0, comma 0, right? 0, 0 coordinates. So what we get from get world location of our controller is the position of, let's do it in red, the position of where our hand is in this world, right? So it tracks the position of the hand. And then get forward vector is basically if, let's say I'm holding out the hand, or I'm holding the gun or the controller, let me use some sort of other color, this direction, right? The get forward vector, what it gives us is a vector that starts from 0, 0, always starts from 0, 0, right? And its length, L, equals 1. It's unitized vector, right? So the length of it is 1. So what we need to do for this to actually work is we need this vector, this guy right here, to actually start from our hand, from this point right here. We don't want it to start from 0, 0. Quick vector math tells us that if we simply add these two vectors up together, like add the coordinates together with the vector, we will be simply moving the vector, right? So it's going to then be placed here. But the length of it is still going to be 1, like 1 centimeter. That is way too small. So before we actually move it, we need to take this vector and multiply it by, let's say, 1,000. So that it's 10 meters long, right? So that's the first thing. I will just take it, multiply. There we go. Here it asks me for like numbers for 3. So if I want to multiply X, Y, and Z separately, no, I don't. So I'm going to right click on this input and I'll choose to integer right here. And then I'll just type in 1,000. So now our vector, the forward vector right here, is this guy right here, 1,000 units long. Now all we need to do is just place it here, and as I said, the movement, the placement is just adding the two vectors up. So from here, add this one, just the plus sign, add up, and then use that as our end, right? It's not necessarily that we are specifying a vector anymore. We're actually specifying, apologies, we're actually specifying a point at that moment, right? So we're actually saying that, yeah, it's here. And it's going to, the line trace is going to create a line between the 2 points. But in my opinion, like explaining it through a vector is is a little bit clearer. Anyway, so every time we will press the button, the trigger, it's going to draw a line that is 10 meters long away from our hand. And the line is going to be aimed because we're getting the forward vector of our hand. Great, we can move on. So then we can say, okay, if this triggers, right, then let's do a branch. Let's create a branch. And if this triggers, right? So if return value is true, then this output will trigger. If this does not trigger, so if we're not doing anything with this, then return value is false. If it's false, we don't do anything. If it's true, we need to do something with, sorry, 1 second, let me think. If we shoot the line, the true statement should trigger some sort of reaction in the world, you know, in this case, in our door. So now is a good chance to just compile this, save this for a while, go back to our, close that, or actually don't close that, sorry. Let's just dock it because we will be revisiting it shortly, but rather going in here and creating some sort of a testing object, which we will be able to trigger, right? So I'm just going to do something very quick. Here under context, I will create a new folder, call it blueprints, double click that. And in this folder, I'm going to just create a new blueprint class, which is going to be an actor, like that. I'll call it interact box. Double click it, and here in this blueprint viewport, let's actually add a box component. You can do so in the left hand side. Under add, you can choose cube. Simple as that, cube. There we go. I don't need it to be fancy, so I'm just going to have it the way it is right now. That is absolutely fine. We will make it rotate around its z-axis when we hit it, right? So now let's go into event graph, and here I'm actually going to delete all of the events, because the event that I want to trigger is actually going to be from a different blueprint, right? So we need to create a new type of what's the word? Apologies. We need to create a blueprint interface, which will be used to trigger. So our line trace will trigger that blueprint interface, and it's going to transfer into our interact box and trigger here, right? So we're basically going to use this kind of a in-between blueprint between the two, between our character and our box that we're trying to rotate. If it's confusing, hopefully once I start building it up, it will be a little bit less confusing. So to make this kind of an in-between messenger, so to say, let's go to our map, and under blueprint folder, let's create an interact blueprint interface. So under here, under blueprint, there is an option to choose blueprint interface right here. I'll click it. Bam. I'll call it interact BP. Let me just double click it to check if there's anything that we need to do. Wait, is that? Seems like everything here is fine except that, okay, so when you do interact BP, when you open up your interact blueprint, make sure that your function is named something that you will recognize. In this case, I'll just call it interact. There we go. And here there's the description category. We don't really need to do anything else here. We just name the function. That's about it. We compile this, we save this, and now we have like an in-between messenger that is going to get triggered by our character and will send the information to our box. So how do you, first of all, how do you trigger it? Well, you need to create like the interact message right here. So you need to message it, right? That you're being interacted with, like that. The name interact comes from this function right here that we have renamed, right? So whatever function name you gave it here, that is the name that you're going to be writing right here, right? So in my case, it's interact. Okay, then when this is true, we send the interaction, or we trigger the interaction into, what's the word? Into this interact blueprint. Okay. Now the question is, how does it know if we have like five different doors? How does it know which door it should send the information to? Do we need to create separate interact blueprints for every separate door? No, we don't, because there's the target, right? The target is what object that receives the interact message that, yo, we should trigger, which object is it? And we can say which object it is by asking the question by, okay, which object is being hit by our line that is shot out of our pawn? So output hit, we drag out of it and we type in break hit result, and we expand it. The thing that we want is called hit actor. I believe hit component, no, hit actor. That's the thing that we want. And it basically is going to say that, okay, by shooting the pointer, the line, you hit the box, our interact box, you hit that, and then the interact blueprint will transfer that information that it's being hit into the interact box, right? So this will just send it over. Okay, we compile this, we save this, then interact box right here. We will use interact. 1 second. I need to remember this one, because it needs to be like an event, I believe. Let's try this. Event interact. There's no event interact. Oh no, I'm forgetting something important. Give me 1 second. I'll figure this out. I remembered what I forgot. Okay, so under we don't have an interface kind of connected to our interact box blueprint, the one that we will use, that will spin, right? So we need to go to our class settings right here. Then under interfaces, you can see that there's no interfaces at the time. So we need to add implemented interface, and here we type in interact blueprint, this one right here, interact BP, right? Now we can see that a new interface is created here that can be used to trigger an event inside of the box, an event of spinning when we shoot at it. So we compile, we drag over this function, 1 second. Maybe it's just interact at this point. Call function, yes. Yeah, call function interact. Nope. Oh my god, event interact. There we go. Finally, it's event interact. We just create one here, and then we will specifically just say, okay, when this triggers, the box should spin. So let's create a timeline, or rather, yeah, let's create a timeline. Add timeline, like that. Call it box spin. Doesn't really matter, right? Then let's go for F8. No, not F8, sorry. Just double click on it. Yeah, double click on it because we need to add a track to the timeline. So click on the add track. Well, before you add it, or I guess you already did it. So let me add, or no. sorry. Again, before you add the track, let's change the length of the track. So how fast should the door or box in this case spin? 1.5 seconds should be good enough. You can adjust this later down the line, that's fine. And the track that we're going to add is going to be add a float track, like so. And we can call it box spin. Box spin. There we go. So over the course of 1.5 seconds, the output at the start should be 0, right? And the output at the end should be 1, or should be like the amount of degrees. So let's do 90 degrees. So let's right click, add key right here, and say that our time is at 0, the value is at 0. That's great. And then the next one, add key, right here, the time is at 1.5, but the value is at 90. Oops, did I mess up? 90. I believe there should be, yeah, zooming in. Okay, so I did mess up. Time 0 or time 1.5, value 90. Again, press the zoom to fit horizontal, zoom to fit vertical. So now you have this kind of a motion going on from 0 until 1.5. The motion is going to be linear, so it's going to start sharp and it's going to end sharp, right? So the animation is going to be a little bit jerky. So to fix that, we will just right click on both of these key points right here, and we will choose that it should be auto smoothness here, auto smoothness here. That will just make it kind of make the transition nicer. Okay, once that is done, we can compile, save, go back to our event graph, and we have our little animation that is going to play. Well, right now it's not even an animation, it's just a number that's going to be increasing. With that number, we need to actually rotate stuff. So we will set relative rotation for what? For the cube. For now, just, I guess we can rotate the whole scene. Yeah, default scene root for now. Set relative location, default scene root. Oh, not location, sorry, rotation. Default scene root. Like that. The update goes into the trigger box right here. And the rotation is going to be translated from the box spin output here. So we're going to make, or we can drag out from here, make rotator, just here, make rotator. And we're rotating around the Z axis, so we just connect box spin to Z, like so. Compile, save. I believe that is it. Now we can actually try it out. Let's see. One last thing. Yeah, one last thing. Go back to your VR pawn, and here under draw debug type, let's just choose to have persistent line traces. So it's actually going to show where the line is being shot. Okay, let's compile. Let's go back in here. Probably I'll just drop all of the quality right now to medium, just so that it runs a little bit smoother. And I will take my blueprint and just kind of slap it in here like that. That's the interact box blueprint, right? Now let me, one second. Let me grab the headset. Come on, hands. There we go. So I'm just using the. Okay, fine. I'll use the controllers. Come on, register controller. Yes. Another one. Pew. Yeah. Okay. So I'm just going to quickly connect my headset to the computer. It's loading in. And we'll see if that actually works. Should work though. Don't see why it shouldn't. Let's press play. I'm just using stat FPS to see if I can talk, because if the frames are too low, then my microphone does not pick up anymore the audio. Seems like it's gonna work, and I believe we use the right arm to do the test. So, oops, let's move back and let's shoot. Pew! Nope. There we go. You can see. And I actually can only shoot once because now it's rotated 90 degrees and we can't shoot it more. But that's the line trace, from my arm. Pew, 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 pew. Seems to work, and it did rotate. So we have a working blueprint. Yay! Now let's make it nice. Now, since it works, let's make it nice. So the first thing to do is actually to, interact blueprint, we don't need it anymore. We can close that, but interact box, we need to somehow, the first time we shoot it, it needs to rotate 90 degrees forward, and next time we shoot it, it needs to rotate 90 degrees backwards. So to do so, we need to create a new variable. I'm just going to click the plus sign here under variables, and I'm going to say open, or box open. I know it's not open, but let's say the trigger it's either open or closed, right? So it is a Boolean, and I'm just going to drag it in here, get box open, like that. And by default, I believe we should say that it's, is it open or is it closed? Doesn't really matter. So for now, let's just say that by default, it's wait, let's compile. Let's have it closed, right? So it's unticked here. Okay, now with this done, let's create a branch here between interact and box spin. Branch, and when it is closed, right, it should open. So we should play the animation. But when it's open, when this is true, when open is unticked, that means it's closed. So when it's closed, it should play from here. Or we can do it this way, like that, and this is tick marked. Okay, that's gonna work. And then when it is, so I'm tick marking the box open, tick mark here. So when it's true, it should play forward, and when it's false, it should play reversed, right? So that it closes. Okay, that should work in terms of opening and closing, but now as we close it or as we open it, the state of this box open should flip from whatever it was before. So I'm going to, let's do it this way. Under box spin, I'm going to ask, is this number larger than, greater than 1? So are the degrees greater than 1? And with event tick, I will set my box open. Come on. Set my box open. So you just drag out your box open into here and you choose to set it to be true, because the moment when the door or the box in this case opens up by more than 1 degree, this will trigger that it's true and it's going to go in here and say that this is true. Okay, so this should technically work. Let's see. Let's compile this, save this, and play this. Put on the headset real quick. Okay. And shoot. Well, okay. That didn't work out at all. Okay, let's see what we're dealing with here. So to troubleshoot these kind of things, what you do is you create a print string node. Print string. In this case, if this event triggers in my interact box, also I should compile and save this. If this event triggers in my print string, interact box blueprint, then print string will be ran. Okay, let's see. Bam. Yeah, you can see that every time that I hit the box, a hello appears on the screen. That means it's triggering. Okay, that's a good thing. Then the box open should run this. Oh, but the box open should be unticked then? No, it should be ticked, right? It's always okay. So another thing that we could do is we could check what happens after the animation, as the animation updates right here. So I feed the print string in between, and I will connect the box spin, so that those are the degrees, into the string input right here. Compile, save, play. For some reason it goes straight to 0, which is weird. I think I messed up here with the branch. Okay, so let's think about the situation here. If the door is open, this should play in reverse. Oh, okay. So it should be like this, crossed, right? So false should play, true should be in reverse. Now this should probably work. Yeah, there we go. Forward, backwards. Okay, so it was just the... Nice. It was just this logic right here that I messed up. So I had the door already open and I tried opening it again, so it just didn't work. Or I had the door closed and I tried closing it again and it again didn't work, right? So that's, yeah, that ain't good. that ain't good. But now it works. Okay, so in terms of the blueprint, here we are kind of done, right? Now for our VR pawn, I still want to do one last thing before we move on. The line trace is quite ugly, so instead I have prepared, let me just open it up to show you. Okay, you can't see it in here, but you can see it in this icon right here, paw.png. This is just a little paw that will show us where we are shooting, you know, instead of that ugly line. So the way you put down the little cat paw at where you shoot, you first need to, of course, create, or not create, but import the paw.png into your, what's the word, into your project. So I'm just going to create a new folder here under blueprints folder, widgets. Probably shouldn't be widget. Should call it something else. Whatever, it's gonna be widgets. Under widgets, I'm just going to drag and drop in the paw texture. As simple as that. Then in my VR pawn, I will say, okay, every time we hit something, it should get a normal vector of that thing, and it should place a paw there, right? So we will drag off from here and call a spawn decal at location, like that. The material that is going to be used is going to be a decal material that we will create from the little paw that we have. That's in a little bit a little while, but first let's just say decal size is 5 by 5 by 5, and the location where it's actually placed is going to be, well, you guessed it, the location of where the beam hits the building or, you know, any geometry. So that's the location. Rotation, though, is going to be a little bit trickier. I'm going to take the normal, but I want every time the paw is placed, the rotation to be kind of randomized, right? So that it's not always being placed at exactly the same angle. That would look weird. So I'm going to take the normal vector and I'm going to say, okay, give me the rotation from x vector. Rotation from x vector. There we go. Then I'm going to take that rotation and I'm going to break it. Break rotator. Like that. Not into axis, just break rotator. X roll, pitch, and yaw. So we don't mess with roll at all. The roll, we don't mess with pitch and yaw at all, but we do mess with roll. So I'm going to make rotator like that. Y and Z just come in straight up, but the X is going to be randomized. So I'm going to just say, okay, give me a random float. Random float is float number is a number that has a comma and a bunch of numbers after the comma. Integer is a number that does not have a comma and is just a full number, right? So float, just a random number, please. Most likely in between 0 and 1. Yeah, returns a random float between 0 and 1. So we just multiply that by 360 degrees. So it's gonna be like a random paw placement at 360 degrees. And that connects to the rotator like that. Great. That's our return value, which goes straight into rotation. And then for how long does the paw stay on the surface? I would say like 5 seconds, something like that. So I can play around with it. And with that, this is almost done. The only thing that is missing is the material. Okay, let me compile this real quick. And then here, let's just create a quick material for, I'm losing my breath, for the pawn. Not pawn, paw, for the cat paw. So I'm going to create a new material in my materials tab here, call it cat paw, like that, double click it. And here I'm just going to add in a texture sample. Perfect. And the texture sample, of course, will have our paw PNG texture, like that. You can't really see it, but we will, apologies, we will fix that in just a second. Okay, I'm back. I just need to double check that I won't make a mistake. So basically, for the texture sample settings, we don't. Okay. We don't. We don't really need to do anything with those, with the settings here. But for the actual material, so let's select that node. Here, we need to change the material to be translucent, because we want the paw to be cut out, right? Translucent, right here. And we want the domain to be not surface, but rather deferred decal. I still don't know how to call that. There we go. So now we will be using an opacity map, and we will also be using a base color. Base color just goes in straight up like that. RGB straight to base color. Hard to see what the hell is going on. That's fine, not a problem. And then for the opacity map, we will just simply connect the alpha. But before we do connect the alpha, I will just, well, let me show you. If we connect it like so, then we get we get our little paw material right here, right? Like a decal, but maybe it's a little bit too intense. So what I'm going to do with this is, instead of just alpha straight up going into opacity, I'm going to say alpha we subtract from alpha, let's say 0.2, so that our paw is a little bit transparent in itself. And also maybe roughness is a little bit less. Let's say 0.5. So it's a little bit shiny. Okay, save that. For this, then we are pawn. For decal material, we will choose paw, cat paw. There we go. Compile, save. Time to test it out. So I'm going to put on my trusted goggles. Connection lost. Great. That's what I love to see. Okay. Yeah. Shut up. Okay, we're good. Press play. Okay, it's alive. And now if I shoot the gun, you can see that I'm placing cat paws onto any object. How cool is that? So now we don't need to see the laser anymore, right? So under VR pawn, I will just for persistent, I will draw debug type, line trace, I will choose none. Compile, save, play. You can see that it's not that great for moving objects. It doesn't track moving objects that well, but I mean, for what it is, I think it's doing just fine. So let's change the lifespan to like 1 second, and let's change the size of it to like 3, something like so. You know, closer to an actual cat paw size. Okay, that's done. I'm happy. Let's move on. So all of this is using, like, this is all we've created, and this is for the interact right, for our right trigger. I want my left trigger to also do that. So how do we make it work for the left hand as well? Well, I will just drag this over here, Control C, copy, Control V, paste, drag it all the way down here. Actually, you could technically just simply create 2 of them and feed both of them into line trace, but and then or rather use some branching tools. But I think this is a little bit clearer, and you can do separate arms for separate functionalities. So we're just copying that whole thing. And here for enhanced input action IA interact right, instead of that, we will create interact left, IA interact left, like that. Started is here. Is it started or is it triggered? No, it's started. Yeah, it's here. And then for motion controller right arm, delete that, and we get one that is motion controller left aim, left aim. Get motion controller left aim, and connect that to world location and forward vector. That's it. That's all you need to do. Everything else kind of stays the same. So now we have both hands that can open up stuff. If you're holding a gun, the interaction blueprint will change or not. How are they called? 1 second. Poop. Input. Mapping context. The input mapping context will change, and you won't be able to open doors if you're holding a gun, but that's fine. Okay, now back in our interact box, we most likely want to do something with this, right? Actually make it into a door or something. So to do so, we will create a copy of this blueprint, because this as a baseline, this is absolutely fine, but we don't need, for instance, the print string, and we want the geometry to be that of an actual door. So I will go to my blueprints, interact box, I will make a duplicate of it, like that, and I'll call it door or interact door. Interact door. Double click that. No need to see the interact box anymore. Close that. So for interact door, event interact is still the same. Branch, well, probably we should rename box open into F2 into door open. Door open. Then box spin, probably F2 gets renamed into door open ning, door opening. What else? Or let's do door opening timeline. That's gonna be a better timeline. Then here box spin, so we need to go in here and change our track rename to door open. Okay. And I believe that that's all we need to do to kind of reuse this blueprint, right? Back in event graph, everything else seems good here. So let's move back to our viewport here, where we have our cube. And instead of the cube, we need to actually use a static mesh, that of a door. So which one? I guess this one, right? So we're going to select this this object, and it's called brep326. So back here under interact door, instead of the cube, delete that. Also, we don't really, do we need, 1 second, I'm thinking. No, we just add in a static mesh, like so. And I'm just going to call it door. You can also drag and drop in if you want to your static objects. That works just fine as well. But static mesh door, and here I will just find 326, right? brep 326. Now that becomes a door. Yay. Okay, now we need a handle. So back in here, I'm just gonna select the handle. Box 027. So another static mesh. Handle 1. Handle 1. There we go. And that one is going to be 297, no? 027, 027. Box 027. There's our handle. As you can see, the handle is wrong. Also, we need to be slower with our camera speed. We're way too fast. The handle position is like it's placed right at 000. That is incorrect. So we need our handle to be actually something like that. Okay. And yeah, of course, I will need a copy of this. And it will need to be placed on the opposite end as well. So let's just duplicate it. Handle 2, like that. Move it over here. So it fits there a little bit better, but this one needs to be rotated. So let's go for rotation, or is it, 1 second, thinking, no, it's just rotation, right? Rotation around y-axis 180 degrees. There we go. Now let's turn off the snapping. Let's move in this one so that it fits with the door as well as it can. There we go. Let's select that one. Move it over here. F. You can use F to focus, and if the camera is clipping your geometry too much, you can use the command R, something with clipping. Near clipping. Set near clip plane. R dot set near clip plane. Spacebar 1. And that is going to be then clipping only 1 centimeter away from the camera. Quite useful. Okay, so we have our handles here. Those work just fine. We have our door here. Let's just check. I'm gonna select both of the handles, see if those need to be pushed in. I think they do. Is that good? That seems to be okay. Yeah, something like that. Okay, great. Now I will select all of these, and I will, or rather, sorry, before selecting all of these, I will create one more one more object that is called add. It should be called a scene, like this scene object right here, and I'll call it pivot point. The pivot point is going to be a point around which the door rotates. So it's going to be, think of a pivot point as a group that will force the rotation. By rotating itself, it will force the rotation of everything that is inside of the group. So the door and the two handles. The pivot point, well, should be placed at the pivot of the door, somewhere here. F, nope, not even close. It's a little bit annoying catching the actual pivot, but with a little bit of practice, you will be able to. I think that is as close as we... actually, if we go even slower... Yep. There we go. Something like that. So that's the point around which the door will open and close. Okay, let's add some materials. So if I remember correctly, that is just steel and that is going to be oak veneer. Okay, materials for the door, oak veneer, and materials for the handles, steel. Brush steel or just steel? For now, let's just have it as just steel. Okay, now the only problem is that door handle, and pivot point, they are disconnected. So actually, door and the two handles need to be connected to the pivot point. So I just selected all three of them and dragged them on top of the pivot point. So now let me show you. If I move the pivot point, you can see the door and the handles, they move together, right? So now I reset the pivot point position to 0, 0, 0, and you can see that if I rotate my pivot, the door opens up and closes. Actually, is that fine? 1 second. Minus 90. Okay, it might need to become a negative opening with this pivot. So we'll see. Should be fine. Okay, we compile, we save, go in here, and for now I'm just going to place the door real quickly right here. There it is, and let's just test play. Okay. So now it works. I just needed to reset the headset. So now if I press play. And I take one of my hands, go next to the door, hit it, opens up, closes down. But now if you can see, the door opens to the wrong side, right? I wanted the door to open towards me, right? Just like there. That door needs to open towards me. So I kind of want the rotation to be in the negative, which is very easy to fix. So here, escape. I'll go to my interact door. For event graph, I will just say, okay, the door open should be negative, right? So negative float. Oh, sorry, we can just multiply it by -1. Multiply -1. Like that, right? And that connects to the Z yaw. And the only thing that I need to also fix is here with what is considered that the door is open. The door needs to now be smaller, less than -1, right? Because we're going opposite, right? So if we're multiplying it needs to connect like that. Because door open, from 0 to 90 degrees, goes until here, becomes from 0 to -90 degrees. And then we say if it's at least -2 degrees, it's kind of open, right? So save that, play that. Let's check which arm is this. That's the incorrect arm. Get there. Pop. Yay. Close. Okay, great. So the position of the door or the placement of the door, the rotation of the door is fine. Actually, I want to check one thing. 1 second. So if this one also still works, that's great. Let's grab. Yeah. There we go. Where am I? Sorry about that. So if I just go somewhere here, rotate, put down the ball right here carefully, and open the door. Yep. I just needed to check if the physics work as well with the door, and they do. Okay. Awesome. That is kind of done with the door. Let's place it in the correct position. So I'm just going to move it right there. Just like that. Bam. And is that bigger? 326. Is my door smaller? Wait, what? 326 and this one 326. Okay, that's weird. This one is actually weird because this door, for some reason, is larger than this one. Oh, never mind. It was just sunken into the ground. That's my bad. That's my bad. Okay, so that's that. I can see that the handles are a little bit too high up, so I'll need to fix that. And also this is lagging, so I'm just going to change the preview of this to be a little bit less, like less demanding, so unlit. Let me drag it in here. This is not gonna be very accurate right now. Usually for it to be accurate, you kind of need to do some math with the existing position of the door right here. Right, so you just select the door, you get the coordinates, and then you kind of do some math with applying those coordinates. But in this case, screw it. We're just gonna wing it. Something like so. I think that is actually oh, never mind. Let's move it up. I think if we do 0, that's actually gonna be correct, right? Does it have a gap? No, it doesn't. Okay, so 0 is actually correct. And now we just need to move the handles down a little bit. So back in viewport, I'll just select the 2 handles that we have. I will assume that they are at 90 centimeters in height. Compile, save, look at the template. They were not at 90 centimeters, they were at a meter. Save. Hello? That's weird. Wait. Am I not? Oh, wait. Is it just this one? Yep. It's just that one. So that one also a meter above. Compile, save. Yep. That's good. So now I can just delete the other 2 handles from here. Just get that one in. Delete. Yes. Get that one in. Delete. Yes. And congratulations, you have a door. Maybe also minus 64. Let's go for minus 60. Or rather, minus 70. 5 centimeters deeper in. Does that look better? Maybe it does. Maybe it does. So minus 17. Okay. That, save. Let's play. Let's take a gander. So I'm just gonna grab my arms. You can see them here. Let me move slightly away so that I can teleport better, easier. for instance here, and then pew, ta-da, pew, pew. Hey, come on, go here, pew. There we go. Ta-da. Oh, don't like that. But yeah, that seems to work just fine. I'm happy. Okay, so now we're looking at this in medium preset, which of course will make it look pretty bad. Let's go back to high preset. Press play. Oh, it crashed. Of course. Now you can replace every single door with the new door that you have made with that blueprint. So with this crash, I'm going to, of course, rebuild the whole damn thing, but then we will go on to, let's try to restore. Go on to the next thing, which is the sunlight, and we will make the sun animated. That's gonna be nice. And it failed to rebuild anything, so let's see how much we lost. Is that a blueprint? That is not a blueprint, but that is, so that's good. Okay, let me fix that, and then we will continue with the dynamic sun. Okay, I fixed it. I fixed it. So now everything works, everything is stable again. As I said at the start of this course, the name of the game is stability and making things work. Barely. But it does work, I promise. So now, dynamic light. How do you make... I mean, we're using lumen. Everything is movable, meaning it would make no sense that the light is not movable. So we need to use that. Now with lumen, let's go in here. And let's first of all find our actually, the first thing that I want to do is get our player start node right here and just kind of move it inside of the building. Just there. Because now we're going to be constantly looking at things from inside of the building. And also this is very slow. Let me just pop back to 0.33. That's great. Okay, so that's step number 1, I guess. Getting the person in. Step number 2, opening up the level blueprint. So that's the blueprint that controls the behavior of the world. Getting a sun that rotates around the sky over time in your level is definitely, like, it should be controlled through the level blueprint. So open it. There we go. And here we have our, actually, let's make it a little bit smaller. Because here we have our event begin play, what happens when you start the level, and event tick, what happens at every millisecond or every tick of the, it's 20 minutes, of the level, right? Within the level. So this is for something that's dynamic, and our light is going to be dynamic. So the first thing that I want to do is I want to get my sun in here. And my sun is a directional light, which we will fish out. There we go, directional light. That is the sun. I'll just get it in here, like that. You just drag and drop it in from the outliner. Now we have it, and I'm going to ask, what is the current rotation? Get actor rotation. Oh, thank God. I thought that maybe they removed it. Okay, get actor rotation. So I get how this sun or this directional light, I get these numbers basically. Minus 105, minus 31, minus 14, right? The rotation. Then I want to set I want a variable, and I want to set my current rotation of the sun to be that of the directional light that we have, right? So I'm going to just, actually, we need to create a variable first. Yeah, new variable. And I'll just call it sun rotation start, sun rotation start variable. And it's not going to be a Boolean, so I expand that. It's instead going to be a rotator, like that. I drag it out here, set sun rotation start, and connect my get actor rotation to sun rotation start. And as we begin playing, it's going to set that. Okay, so it's setting it up, that's great. But now how do we keep it, make it rotating, make it rotate? So for that, we need a number that keeps increasing over time. And the best way to do it is to create a variable that you call a counter. And that variable should be a float type variable. And we just get it in here and we get the counter, right? So it starts from 0 and we add delta seconds to the counter at every tick of the level. So pum 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 pum, every tick it keeps adding milliseconds to our counter, right? And then as it's adding them, it should set counter. Let's do it this way. Drag out the counter from here, set counter to the new added value. So first tick, let's say this is 0, 0.2 is added, this becomes 0.2, this is now set to 0.2. Next tick, this is 0.2, 0.2 more is added, right? So this is now 0.4. Next tick, 0.4 is here, 0.2 is added, this becomes 0.6, and so on, right? So it keeps increasing, the counter keeps increasing in its size, right? In its number size. Okay, now I want to rotate the sun with this counter. To do so, I will just set actor rotation. I believe it's not relative, it's just rotation. Set actor rotation. Oh, that's cool. Already chosen directional sun. If it doesn't, you can just drag out directional sun again and connect it to the target. That's fine. And I'm going to say, okay, after you've set the counter, you should rotate the sun, right? So we connect it like so. Let me expand this. So now it's going to be triggering this every time every tick of our level, right? So every 0.02 seconds, I believe. New rotation is going to be a little bit of a tricky one because we need to understand what roll, pitch, and yaw is for the light, right? The roll for the light is nothing. We don't care about the roll because it's if you have a projector, the roll is this, right? So if you take a projector and you roll it, the light will not really change much, right? So, okay, if I take sun rotation start, right? At the start of the level, we get those angles. Change it here. At the start of the level, we get those angles for the current sun rotation. If I take that and get sun rotation start, I can break rotator. I can break it into roll, pitch, and yaw, right? And this new rotation also needs to be broken into roll, pitch, and yaw. So let me right click on it and choose split structure pin. Bam. As I said, roll doesn't matter, so I just connect it like that. That's fine, that's whatever. But pitch and yaw should be controlled, right? And they should probably be controlled. One should be quite linear because it just goes around, while the other one should be more of a sinus curve, right? It goes up and down and up and down, right? So which one should be a sinus curve, you know, for the up and down movement, and which one should be just linear going around? Good question. I believe the yaw, the Z, is going to be just around just a constant, and y will be a sinus. If I, yeah, I think that is the case. Okay, so let's get a counter in here. Get counter. And let's just say, okay, this counter should go through a sinus in degrees, like that. And it should be remapped to a certain kind of threshold. So map range clamped. Map range clamped, and sinus always goes between -1 and 1. So our in range A is -1, in B range is 1. So the outputs here are kind of sandwiched between A and B. The output, so as the sinus curve is lowest, what kind of degrees do we want for the rotation in Y? I think, let's go for like -5 or -10. What's the current? Actually, current angle will give us an idea. So the current angle is -31. The current angle is -31. So perhaps. 1 second. I'm thinking. I'm gonna figure it out. Yeah, that should be fine. So -10 and 10, something like that. All right, so 10 degrees up, 10 degrees down. And the return value gets added. We need to add it to the existing pitch, right? Plus add to the existing pitch. So we'll start from the original position and we'll start adding the angle to it, right? New rotation, Y, pitch. Then for so that's our sinus curve. Then for our yaw, that should be also added. I think we just straight up just kind of connect the counter to it like that, honestly. I think that's gonna work. Later I'll show you how to speed it up or slow it down, but for now I think this is going to be just fine as a baseline, just to test. Okay, let's compile it. Put on the headset. Okay. So this should work. I lowered the quality of lumen a little bit. Lumen under post-process volume, lumen scene lighting quality 0.5 and lumen reflections quality 0.25. So now you can see that clearly the reflections are much more shimmery, right? And also in general, there's much more shimmery stuff going on. But if I think it's alive now. So it takes a while for it to kick in, for it to warm up. But once it's done, then we have everything working quite nicely. Still a little bit jittery, that's fine, but at least the light works. So let's move around and see. Right, here we go. The light is rotating. And everything is super dynamic. Let's just quickly go to here, because this is going to be a place where the light is gonna start hitting, so that should be pretty interesting. The next step, of course, is going to be to balance the whole thing and to make it kind of nice, neat, and tidy, but slowly. Also, auto exposure is kind of weird. Like the outside is super dark, but yeah, there we go. That's our sun ray right there, hitting our bedroom. Just give it a moment. Yeah, that's kind of natural, isn't it? Oh, what's that? Oh, yeah, that's from the little grid here. Okay, that's cute. And also my hand, you can see the shadow of my hand here. So that's also pretty cute. Okay, let's go back in here. Take a look. Yeah, that's nice. Go back to the living room, close the door. Can't see where I'm pointing at. There we go. Yeah. Okay. That works. Enough of playing around. Let's make it as the microphone catch that. I said let's make it aesthetic now. The next step is actually to final adjustments, color corrections, blah blah blah, to make it all neat and dandy. Perhaps I want the sun to be slightly lower, so the range needs to be from 20 until, yeah, something like that, because 20 like that goes down, right? It's not like it's going up, that goes down. So we'll make final adjustments, and that's going to be the end of the last chapter, or rather the last chapter is going to be me showing you how to get it as an external exe file that you can send to your clients for them to run it on their own headset. But for now, let's jump to the next chapter. Okay. One thing that I forgot to mention is how do you change the speed at which the light moves. So if you open the level blueprint again, the speed is controlled by in here by multiplying the counter to some value. So if I just multiply by, let's go for 100, let's see what happens. This is gonna be a little bit disorienting, and instead of just the counter, I plug in counter times 100 to my sinus for the Y and my plus for the new rotation. Compile that, play that. Whoa. Well, it works, right? And by the way, if you press tab, you can see that kind of observer camera right there. And actually, let me go and say hi to it. One second. Hello. Hi. That's me looking around. So tab switches between what I see and what observer camera sees. That's just a very nice thing to have in your scene when you are troubleshooting. Okay, now everything seems to be working just fine, so let's save that. And one last thing that I want to do before I can close this, I already did it, so I'll explain it, is I used under event begin play, execute console command right here. I created a new variable by clicking the plus sign right here, named it scalability, made it into string, which is text, dragged it in here, get scalability. So I got this node right here, connected to the command, and basically we want the command to run as we start the level. So what kind of command is it? Under scalability, once you compile, press compile, then you will see a value that you can insert here, and I just inserted in caps lock scalability 2. What this means, or what this does is, let me close that. What this does is it forces the high scalability for your scene. when you will be publishing this project and playing instead of epic scalability. That's important. So basically we're just lowering the quality, right? For VR you kind of need to do that. All right, what else? So now it's time to make things a little bit nicer, just slightly. Oh yeah, and probably we don't want our sun to move 100 times faster than what it used to before. So I'm gonna switch this back to 1. Close that. Now in my environment light mixer, I can start kind of playing around with the different settings. So first of all, kind of want some fog in here. That's too much. That's definitely too much fog. So 0.2 maybe, something like that. It's a little bit on the blue side, isn't it? I don't like that. Okay, 0.1 seems like that's gonna be yeah, a good average. Maybe 0.15. Let's see how that looks without fog. Yep. And 0.15. Okay, 0.15 indeed is pretty nice. If you don't want this kind of fog, but instead you want like a more accurate one, you can choose volumetric fog, which of course costs a little bit of performance. Stuff needs to calculate. It costs a little bit of performance, and also you get the god rays in your scene, which is very nice. But in VR, they don't look as good. They're a little bit too shimmery, a little bit annoying, so I will not be using volumetric fog. Instead, for indirect lighting intensity, I will be increasing that a little bit. That is not a little bit. I'll be increasing indirect lighting intensity of my directional light to 3, something like that. And for my skylight, perhaps also to like 3 or so, maybe 2. This will just make sure that the shadows are a little bit brighter, a little bit nicer. Just a nice thing to have. Okay, now everything seems to be a little bit overkill in terms of the brightness. So I'm going to go to my post-process volume right here. And I will find, what am I searching for? I'm searching for 2 things. Thing number 1 is going to be lumen, global illumination. I will increase the scene view distance to 2000 and max trace distance also to 2000, simply because my house is not that small. So I think if we have like 2000, it's going to catch the whole scene for lumen, which is nice, a nice thing to have. Next up, we will go to our lens flares. I'll change the intensity of lens flares to something like 0.01, maybe 0.05. Let's see. Does it catch any flares? Hard to say. Let's reset it. Definitely a flare there. There we go. And now let's see what we need to drop. 0.1. Oh, even 0.1. No, 0.1 is too strong. 0.03, something like that. Yeah, that will work. Okay, then for exposure, I want my exposure compensation to be like minus 0.5 because it's way over bright right now. I want this to be a little bit on the dark side of the environment. Maybe -1. Yeah, one full stop less. That looks much better. Okay, what else? For bloom, let's use some bloom. And I'm not sure if we can use convolution bloom. Maybe we can, but if the convolution bloom is more accurate. So if the bloom becomes too much, and also let's reduce it, 0.5. If the bloom becomes too expensive on your graphics card, then make sure to reduce it. I think that's it. This feels like it's it. The blue tint is a little bit annoying, but it is what it is. We get our scene here. Sorry, give me a second. I'm just going to make sure that every single setting that I have is okay. You can change the temperature if you want to, like the white balance and whatnot. To warmer or colder, but I prefer to just keep it the way it is. At least for this scene right here. Okay, last try, last test rather. Save. I think we have everything ready to go. Works like a charm. Great. I think it's time. Also, the fog needs to be larger. The fog needs to be larger. 0.3 at least. And maybe let's do volumetric fog, but the scattering, the light scattering, I don't want that. So volumetric scattering, I'll have that turned off. I think this looks better, honestly. There we go. Audio is back. I hate this. Absolutely hate this. You don't... Okay. Real talk. Real talk. You have no idea how many hours I spent re-recording these videos by trying to make the freaking audio work. And by realizing that, you know, I've been talking for like half an hour and none of the audio went through. I just needed to put it out there. It's not easy, man. It's not easy. Anyway, let's move on. So, with this done, I'm kind of happy with it. So it's time for us to publish it. That is the last step that we will do. And the way you publish your project is through platforms, choosing Windows in this case. I will be using the development, I will be publishing it for development rather than for shipping. Simply gives me more, apologies, gives me more logs if something goes wrong. And I will just choose to package the project. Asks me where do I want to save it. I'll just go for desktop, VR test. And here I will just, actually I can name this one old. There we go. And just publish it into VR test folder. Select folder. That's it. It's going. So now with the output log going, it's going to kind of say what it's doing. If you will get an error, then make sure that you have Visual Studio installed. That is probably going to be one of the most common issues that you can't get to work. Honestly, I would suggest, like, since you can have so many different errors that pop up, I would suggest that once you get an error, if you get an error, output log, Control-C, Control-V that error into Google. There's definitely going to be someone out there who has received exactly the same error as you have and already has received help. So that is the way you troubleshoot at least the compilation errors. Those get annoying, but hey, it is what it is. So once this whole thing is done, once it's packaged, then we can try seeing what's up and try seeing how we can play it on our in my living room, right? So how can I play it not in Unreal Engine, but just, you know, in computer? Let me pause the video here. Hello. Okay, so I am kind of ready. We're gonna use the headset for this. By the headset, I mean the microphone on the headset. And now I will load in. What am I loading in? I'm gonna load in the exe file that was made for us. And this is getting dark really quickly, so I need to step up. Okay, let's see. How is this looking like? Runs like a charm. Wonderful. Everything seems to be a-okay. Let's go get our ball. Like that, to one hand. Do we take this? No, we don't need that. Let's take a gun instead. Let's move in here. Up. I do need to go through the barrier, like through the glass, to be able to teleport back and forward, right? Which is, it is what it is. Besides that, seems to be quite stable, quite nice. Look at that sunset. Hopefully, wait, what do you see? 1 second. Oh yeah, okay. You can see it all, that's fine. So the light could be, for my hardware, could be a little bit better. I could now ramp up the... Oh, that's nice. I could ramp up the lumen, global illumination and lumen reflections. But besides that, look, the fog and everything, that seems to be quite nice. Pew, 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 pew. Those guys are pretty bright, ain't gonna lie. But it's kind of nice. Oh. Okay, enough with the gun. Let's put it down on the table. Boop, right here. And, oh, the ball. I still have the ball here. I wonder if it's going to... Yeah, that's nice. Sticks there quite well. So now, where was the door? Was it that one? Wait. Let's do some art. Pew, 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 pew. Okay, so that works. And if I hit the door, opens up just like that. And just in time for us to come in here and see the beautiful light starting to hit this environment. Of course, like, none of the stuff here is grabbable, right? We didn't solve that, but with that being said, I know that it's hard to convey the, how do you call it? It's hard to convey the realism, you know, how much in this space do I feel, but this, I mean, at this point, I would be happy to show this to the client and ask them what they think, because this is close to reality, honestly. Let's go out. Let's go out here. We never looked at this side of the... Huh, that's nice. We never looked at this side of the building. It's kind of neat. What's that? Ooh, that's like a bathroom situation there. We can't get in, can we? Okay, that's a little bit annoying. 1 second. Boop, like that. Boop. Come on. No? Okay, it's raised floor, so we can't get there, but that looks nice. Anyway, keep moving forward. That's the child's room. That's a mistake with texturing. Not the texturing, the UV mapping. Hey, it is what it is. Speaking of which, if you want this file, this whole file right here, consider, wait, am I talking? Where's the camera? Probably here. So if you want this file right here, consider helping out the channel by becoming a Patreon member. You will get the Unreal Engine file that I'm showcasing right now, as well as the Rhino file for, you know, playing along, for following along rather, right? Let's go in here. Put the ball there. Nice. I'm happy. I'm happy with this. With that being said, that's below ground. No, no, the floor. That's fine. We can work with these. With that being said, we are kind of done. Everything is stable. The frame rate is, I would say, probably around, or actually, give me a second. I'll type in. We'll see what the frame rate is at. Let's see. The frame rate, 40 something. I can only see, like with the headset, the frame rate is a little bit off center for me. So I can only see the timings. And the timings for the frames is 22 milliseconds, which I would guess around, where am I? I would guess that's around 45 frames per second. The tiling there is bad. I should fix that. Besides that, we're happy. We're Gucci. Look at that. Look at the dynamic lighting. Yeah. Wonderful. Ooh. All right. That's it. That's it. We're done. We're done. I'm happy. I'm happy. Hope you've learned. Wait, am I talking? Yeah, there we go. Hope you've learned something. I hope you've learned a lot in this course. I really had fun doing it, except for the all instabilities and all of the problems with, this being the first iteration of Lumen and Nanite that actually does not crash immediately with Unreal Engine VR. Once there is an even better, more stable update, I will of course update this course. So be subscribed if you don't want to miss it. And with that, this beautiful sunset, I will say adieu. Bye. Goodbye. Bye.